Hello lovely scholars, welcome back to the Kemet Maasai Academy. Today we're going to be continuing our series of videos on sets, and we're focusing on the set of square numbers, also including square roots, discussion on square roots since it's connected to square numbers. Before I go any further, however, I'd like to encourage you to subscribe to the channel if you have not already done so. Just press that subscribe icon and also press the bell so that you'll be notified whenever a new video comes out. And believe me, these math videos are coming out like a barrage of bullets. So you want to stay on top of things. You want to know whenever these videos come out so that you can watch them and share the videos so your friends, neighbors, classmates can benefit. So let's dive right into the lesson today. We are looking at the set of square numbers. What is a square number? The set of square numbers are obtained by multiplying each natural number by itself. This little 2, the small 2, written to the upper right hand side of a number, we call it square. So we read this as 1 square, 2 square, or 1 to the second power, 2 to the second power. This number tells us how many times we're going to multiply the base number by itself, not by 2, by itself. So 1 squared means 1 times 1, 2 squared or 2 to the second power means 2 times 2, 10 squared or 10 to the second power means 10 times 10. And that's how we obtain our set of square numbers. So we're going to do the first 15 square numbers simply by multiplying the natural numbers by themselves. Remember, natural or counting numbers start at 1. So 1 squared or 1 times 1, that's 1. 2 squared or 2 times 2, that's 4. 3 squared, 3 to the second power, or 3 times 3, that's 9. 4 squared or 4 times 4, that's 16. 5 squared, 5 times 5, that's 25. 6 squared or 6 times 6 is 36. 7 squared, 7 times 7, that's 49. 8 squared, 8 times 8, that's 64. 9 squared, 9 times 9, that's 81. 10 squared, 10 times 10, that's 100. 11 squared or 11 times 11, that's 121. 12 squared, 12 times 12, 144. 13 squared, 13 times 13, 169. 14 squared or 14 times 14, that's 196. And 15 squared, 15 times 15, 225. So if set A is a set of square numbers, then we can list the elements of set A. So we have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. But that's just the first 15 square numbers. Remember, we get square numbers by multiplying the natural numbers by themselves. Natural numbers continue forever and ever and ever. So that means square numbers continue forever and ever and ever, because we just have to pick a natural number and multiply it by itself, and we're going to get a square number. So if the natural numbers continue on and on to infinity, the square numbers continue on and on to infinity. So we're going to put 3 dots, ellipses, to indicate that this set, the set of square numbers, it does not end at 225. By no means does it end at 225. It goes on and on. The square of 16, the square of 17, the square of 50, the square of 5,000, the square of 5 million, on and on and on. So wherever you see a set listed and there are ellipses either to the right end, or even if there were ellipses at the beginning, that would indicate that the set continues to infinity to the left as well, right? Square numbers start at 1. 1 times 1 is 1, right? So, but they continue to infinity. Now, a square root, the square root of a number, of a square number, is that original number that you multiplied by itself to get the square number. So, since 1 times 1, or 1 squared, is 1, then the square root, that's the symbol for square root, the square root of 1 is 1, because you're asking yourself, which number do I multiply by itself to get 1? You're going backwards, you're thinking in reverse. 1 times itself gives 1, so the square root of 1 is 1. What's the square root of 81? Which number do I multiply by itself to get 81? That's 9. 9 times 9 gives 81, so the square root of 81 is 9. The square root of 100 is 10, because 10 times 10 gives 100. So 10 squared is 100, therefore the square root of 100 is 10. Alright, so the opposite of the square numbers are the square roots. Now let us list the elements of these sets, just to prove that we understand what we're doing when it comes to the square numbers. Set A is defined as the set of square numbers that are greater than 4 and less than 90. So let's see, what are the square numbers that are greater than 4? So we're not going to include the 4. It must be greater than 4. Less than 90. So even if 90 was a square number, which it isn't, it's not a perfect square number, where we would not include the 90 either, because it has to be less than 90. So the square numbers that are greater than 4, so we'll start here then. This is the first square number after 4. So that would be 9, 16, 25, 36, 49, 64, and 81. Those are the square numbers that are greater than 4 but less than 90. B is defined as the set of square numbers between 40 and 100. Between. So we're not going to include the 40 or the 100. Whether or not they are square numbers, we're not including them. The ones that fall between. So set B then would be the first square number after 40. That would be 49, 64, 81. Those are the square numbers between 40 and 100. Set C is defined as the square numbers not exceeding 20. Not exceeding means do not pass. Do not pass 20. So we want those square numbers that do not pass 20. So from the first square number up to where it gets just below 20. So that means that would be 1, 4, 9, and 16. Because after 16 is 25 and that exceeds 20. We want to keep it below 20, right? Not exceeding 20. So it's 1, 4, 9, and 16. Finally, set D is defined as the square numbers that are greater than 120. Bigger than 120, those square numbers. So we can use our list to help us because we had worked out some square numbers. So the ones that are greater than 120, so we'd start here. So we'd have 121, 144, 169, 196, 225. But we know that square numbers don't end at 15 times 15. We know that square numbers continue forever. So we put our ellipses to indicate that the square numbers that are greater than 120 go on forever. We put our ellipses, we listed some of them to show that we know our stuff, right? But we're also saying, listen, we are not able to list all the square numbers that are greater than 120 because they continue forever and we don't have that amount of time in our lifetime, our children's lifetime, our grandchildren's lifetime to list those numbers. So we just put our ellipses and we close our curly brackets. So that's it for the set of square numbers. And we also talked about square roots since it's related, right? So a number times itself will give the square number. The square root would be taking you back to the original number. Which number did we multiply by itself to get that square number, all right? So you should know these just like that. You should know at least these first 15 square numbers. You're going to meet them a lot as you progress through your mathematics courses. At least these first 15, maybe you can even kick it up to the first 20, right? Try to know those out of your head just like that. So if I say, what's the square root of 64? You should just be able to tell me, what's the square root of 196, right? Or if I say 10 squared, 12 squared, 13 squared, you should just tell me like that. The first 15, try to know them, study them. If you have been helped by this video, just drop a line in the comments to say, thank you, miss. I will definitely respond. I always respond. You can also let me know if you want me to do any video on a particular topic. I'll gladly do that for you. If it's already done, I will point you to the playlist so you can go and check it out. Remember, if you still haven't subscribed, I'm urging you to subscribe. I'm also urging you to share the video so other students may benefit just like you did. My scholars, continue to do your math, continue to practice, and have a positive attitude towards your work. You can check out our motivational videos as well. Remember, we have videos, math videos from grade 4 to 11, but we also have motivational videos for students to keep you inspired. My scholars, I'll see you in the next video.